Hello and welcome to Technical Utkranti. Today we are going to look into the details of compilation of a C program. Okay, so there are 4 steps into the compilation process. First is pre-processing. The pre-processed output goes into compilation. From compilation comes out the assembly code. The assembly code is then changed into machine code, and machine code is then linked with different executable. Okay, so firstly we'll look into the preprocessor, which is the first step of the compilation process. So hello.c, which you write as a source code, goes into the preprocessor to produce a hello.i file. The instruction for this step is cpp hello.c to hello.i. CPP's full form is C preprocessor. This command expands whatever the hash include hash defined files are there, and it removes the comments from the source code to generate hello.i file. Now I'll quickly show how hello.i looks. Here, as you see, I have included a standard input output header file over here, and I will insert a comment here. We will be running the preprocessor. Let's see what it looks like. So this is some very big file, and towards the end we can find our source code over here. So what is all this thing? This is nothing but the standard input output.h file that we have included at the top. Does this file exist on a system? It has to exist, otherwise the preprocessor itself will not run. We'll see where this file exists in a system. So in Linux, in order to know the location of any file, you can just simply write where is and the file name. You'll get to know that this file exists in user include folder. Let's visit user include folder and see how this file looks like. We'll go to other locations, computer, user. So here you can see there are many .h files, and stdio.h is here. We'll open it, and yeah, if I search this, let's say in the .i file, I should find it. See, uflow overflow and uflow overflow. So you can see that the stdio.h file has come up in the hello world.i file, and we can see that the comment will also be removed from here. See, it has not been able to find. Okay, now the second part is the compilation part. Here hello.i, the source code present in hello.i, is compiled to form the assembly language output hello.s. Okay, this is the most important step, and probably that's why all the 4 steps combined, the preprocessor, compilation, assembly and linking, the combination of all these 4 steps is also known as the compilation in general terms. The command is gcc -S hello.i. It will compile, as I told, the source code to assembly language, which is specific to the processor. Okay, and so if once we see the how does hello.s looks like, we'll get to know that it is not the usual assembly source code as we would have learnt in our BTech times. It is actually specific to the processor that the machine is currently built upon. Okay, and one more observation that we will see is that printf function which we wrote in our source code is present as it is in hello.s file. Why is it like that? We'll see shortly. gcc -s hello world.i. Okay, so now we have hello world.s. We'll open this and see. Yes, see that they should be using. Okay, put s is the alternative of the printf function, right? In because we are outputting the string, it has been translated from printf to put s. Okay, find the assembly source code does not know the definition of put s. It is actually coming from this library file. We'll see. They have defined this put s function as an extern. So for the purpose of compilation, put s could be used in the source code, but if you run this assembly code as it is right now, it will not run, because it has not found the definition. It has found the declaration in the header file, but the definition of this function is still not there. And how will it come into our code? How will it come into our executable? That we'll see in a short. Language code is changed into the object code. Okay, so assembly language is still an intermediate level at which even a human could understand the source code, and it is also very close to the hardware. This lowest level of language is then translated to machine language. After being translated to machine language code, we'll not be able to understand anything what is written here. Okay, so we'll run this command and wait a second. Okay, -o. Okay, -s was not there. I'll let's remove this from the slide as well. Sorry for that. And we have hello world.o with us now. And now I'll open it and you will not understand. Okay, it can't display also, so it's okay. Okay, so my question to you now is, will hello.o run? It will not run. Why it will not run is that the put s function which we were seeing in the assembly code has still not found its definition yet. How will it find its definition? It will find its definition only after the next and the final step, so which is linking. So what does linker do is, it will take multiple object files, okay, and it will link all of them with your object file to produce the final executable. Okay, so the put s function which was declared in the header files will find its definition in these object files, which are like present in different root folders in our system, and all of them would link together to form a final executable, and this one would be finally able to run. The command of this step is fairly complicated, and to be fair enough, I also did not go deep enough inside it to understand what exactly is the command. If you know the command, you can write in the comment box. I'll also learn from it, but I would say that you can straight away run the source code itself, and using this command you can directly produce this executable. gcc hello world dot c -o hello world dot o. Okay, and then you can just run this. You get it. Okay, so these were the steps. We'll quickly see some extra commands in GCC which you can add into this command of generating the executable. Sorry, last minute changes. So now if I run this, we'll see what are we able to run it or not. First of all, okay, hello world. This is hello world. This is just the name of the output file, so we can keep it as whatever we want. Yes, it runs, and I run hello.o. Yeah, it is running fine. So we'll quickly see what does these flags signify. So wall option actually enables, it tells the compiler to generate like more warnings. -G option is to enable the debugging. If you want to debug your code later on, you have to compile it with -G option. And -O option is to tell what is going to be the name of your output file. So as you know, like we had a source code named hello world.c, and the executable that we finally produced was hello.o, which we can do. Okay, and we'll quickly see now a little bit of debugging. Okay, you can look into these commands. These are just a very small number of commands. Actually, in GDB debugger you can find a lot of commands. You can search it on the internet. Let's quickly see. We had already compiled it with -G option. So what I'll do is I'll just run gdb hello.o. Okay, so now my system is ready for running the debugger. I'll apply the breakpoint at the main function. Okay, after applying breakpoint, I'll just give a run, and when I gave run, now my program ran and it halted at the main function. Now you just press Ctrl X and A and you will get a better view during the debug. Fine. Now to move further ahead, you can either use the key S or you can use the key N. N means next line, S means step. So S has to be used when there is some more service which is being called, and in that service you want to step in. Okay, so that's the difference between S and N. Give N, N, okay, and then you give N, 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 N. So as you can see, you can see the flow of the code. You can use the function disp c. Okay, so you can see what is the value of this different resources in the code. You can see in which loop you are. You can delete the breakpoint also. So as you can see, the breakpoint is currently at line number 4. You can delete it, so it's gone. Now you can apply breakpoint at, let's say, hello world.c at line number 8. Let's say it was just to tell you that breakpoint could be applied not just at the name of the service but also at different line numbers as well. Okay, and once you are done debugging, you can just give a Q and it is done, right? So that was a small tutorial on compilation and debugging. I hit a like, and you can also comment on how can I improve the quality of these videos further. Thanks a lot. Bye bye.